Okay, let's consider an example or a few examples of this process of phase change. So before we do that example though, let's think about what we've learned so far. So we know that heat is transferred during a temperature change. So if you want to change the temperature of an object from a high temperature to a low temperature or a low temperature to a high temperature, you're going to have to either remove heat, remove energy, or add energy, and the amount of energy required, the heat transfer, in order to change the temperature of an object depends on the mass of the substance and its specific heat capacity. And so we know that anytime there's a temperature change, then we're going to have to add or remove energy. And we also know now that if we want to change phase, that the amount of energy that we're going to have to transfer is going to depend on the mass of the substance and the latent heat. And the latent heat depends on what type of phase change that we have. And it also, this phase change has to occur at a very specific temperature for a given material. So those are some things to keep in mind. So in our first example, we're asked to figure out how much heat must be added to 200 grams of ice in order to completely melt the ice at standard atmospheric pressure. So we're going to assume that our ice starts off at negative 20 degrees, and we want to take that and convert it into liquid over here, and we want to completely melt the liquid. So the first thing that we should realize is that our ice is at negative 20 degrees Celsius. It is not at the point where it can actually melt. So we actually have to put some energy in and change the temperature of this ice that's now at negative 20 degrees Celsius, and we need to get it up to 0 degrees Celsius. So we're going to add energy in order to change the temperature of the ice, right? So it can't melt until it's at 0 degrees Celsius. So I look at that number and I say, all right, what is the process that has to occur in order to go from this solid at negative 20 into the liquid? So first thing that has to occur is to get my solid at its melting point, and for ice it's at 0 degrees Celsius. So there's my energy required for doing that. Next, I can go and I can melt my liquid, right? So it's now at the temperature where it can melt, and so I can add some energy for that, and I can have a phase change occur. And during the process of melting, the temperature stays 0 degrees Celsius, so after that liquid is completely melted, it will be at 0 degrees Celsius. And I've just been asked to figure out how much energy has to be added in order to completely melt it, so I'm not worried about raising its temperature. So I have energy that's required to change the temperature, and I have energy required to change the phase. So the total amount of energy would be adding these two values together when I figure out what they are, and then that would give me the total amount of energy. All right, so let's look at what we have. So we have our picture from the previous page in terms of our transition of what has to occur. And we should write down what we have that's given. So we know the mass of the substance is 200 grams, and we know the initial temperature of the ice is negative 20 degrees Celsius. Some things that were not explicitly given in the problem, but are things that we have talked about in other presentations, are the specific heats of materials, or even if we hadn't talked about them in other presentations, we certainly could look up those values. So we could look up the specific heat of ice. In this case, we're going to use calories per gram degree Celsius, and the specific heat of ice is 0.5. The specific heat of water is 1. And then latent heat of fusion, which is the melting process, is 80 calories per gram, and for vaporization, it's 540 calories per gram. So, so the first process that occurs is I have my ice that's at negative 20, and I need to raise the temperature of the ice to 0 degrees Celsius. So here is my energy required to do that. A very common mistake is to choose the wrong specific heat capacity. Because the substance is in its solid phase, it's the specific heat of ice that I have to use because I'm changing the temperature of the ice. So I can determine the amount of energy required to change the temperature of the ice. My Q value here would be dependent on the specific heat of the ice, the mass, and the change in temperature. So the mass of the substance is 200 grams. The specific heat capacity of ice is 0.5 calories per gram degree Celsius, and my temperature change is going to go from -20 to 0. I don't care at this point about pluses and minuses, I just care about the difference. And so the temperature difference between -20 and 0 is 20 degrees Celsius. So the amount of energy required just to take that ice and get it up to 0 degrees Celsius is 2,000 calories. Now that my ice is at 0 degrees Celsius, I can put more energy in and I can melt it. And the amount of energy required to melt it depends on the mass of the ice and the latent heat of fusion. So I know the mass and I know the latent heat of fusion. So I have to choose between fusion and vaporization. Since I'm going from a solid to a liquid, I would use the latent heat of fusion. So my mass is still 200 grams. My latent heat of fusion is 80 calories per gram. So the amount of energy required to take that ice that's at 0 degrees Celsius and completely melt it would be 16,000 calories. The total amount of energy I would have to put into the system is the addition of the energy for both of these processes, which would be 18,000 calories. So the best approach to solving problems, I think, is to draw a picture similar to what we did here. Think about where you have to start, which is where we started here, and then where you have to end up, and then think about the processes that have to occur to get to that final stage. So here's another example. This one is a little bit longer, and in this particular example, we're going to actually use units of joules instead of calories. So the question is, how much heat must be added to 1 gram of ice? So here's my solid ice that's at -30 degrees Celsius, and I want to take that ice at -30 degrees Celsius and I want to change it into steam at 100 degrees Celsius. And I want to know how much energy am I going to have to put in for this process to occur. I'm given the specific heat of ice in terms of joules per gram degrees Celsius, specific heat of water, latent heat of fusion, and latent heat of vaporization. So let's think about the process that has to occur. So I obviously have to start off at -30 and I want to turn it into a gas. I can't just go from the solid to the gas. I have to take that solid and I need to convert it into a liquid, and then I need to convert that liquid into a gas. Before I can convert this solid into a liquid, it has to be 0 degrees Celsius. So the first thing that has to occur is I need to get that block of ice up temperature-wise up to 0 degrees Celsius, which is its melting point. So there is a certain amount of energy that's required to change the temperature of the ice from -30 up to 0 degrees Celsius. After it's at 0 degrees Celsius, I can do a phase change. So I can convert that solid into a liquid. And there's a certain amount of energy required to do that, which depends on the mass of the substance I have and the latent heat of fusion. I now have water at 0 degrees Celsius. I want to convert it into steam at 100 degrees Celsius. I cannot do a phase change of water at 0 degrees Celsius. The water has to be at its boiling point. So I need to do a temperature change, and I need to get that water up to 100 degrees Celsius in order to convert it into steam. So I'm going to have to put some more energy in to change the temperature of the water from 0 degrees Celsius up to 100 degrees Celsius. And then finally, I have water that's at 100 degrees Celsius, and I can convert it now. I can do a phase change because it's at its boiling point, and I can convert it into steam. So there's a certain amount of energy required to do that. So this problem is more complicated in the sense that it looks like a very short problem, but there are steps to follow to get to that final answer, and I actually have to figure out the amount of heat required for 4 different processes, and then I can add them together. So here is my picture from the previous page, and we can look at each one of these cases separately. So I'm going to start with my ice, and I'm going to change its temperature to 0 degrees Celsius. And so the amount of energy required for that is the mass, which is 1 gram. The specific heat of ice, because ice is what is changing temperature. And then the temperature change is going from -30 to 0, so that's 30 degrees Celsius. So the amount of energy required to take that ice and get it to 0 degrees Celsius is 63.3 joules. I now have my ice at 0 degrees Celsius. I can now phase change it from a solid to a liquid, and the energy required for that is the mass times the latent heat of fusion. The mass is 1 gram. The latent heat of fusion for water is 334. I think before I might have written it as 333, but it's around 334 joules per gram, which means it requires 334 joules of energy to take that 1 gram of ice and convert it into a liquid. Now I have a liquid that's at 0 degrees Celsius, and I want to get it up to its boiling point, so I have to put energy in to change its temperature. And that's the mass times the specific heat of water, because I'm changing the temperature of water now. It was ice, but now it's water. And I'm going to change its temperature by 100 degrees Celsius. So the amount of energy required for that is 418.6 joules. Finally, I have my liquid at its boiling point, and I can do a phase change into a gas. The temperature stays the same, right? During the phase change, it was at 100 degrees Celsius. It's going to be at 100 degrees Celsius later. So it's the mass times its latent heat of vaporization, because the phase changes from a liquid to a gas, and so it requires 2,260 joules. I want to point out again that during the phase change process, the temperature remains the same, right? So here's a phase change from solid to liquid. The temperature stayed the same. Here's a phase change between liquid and gas. The temperature stayed the same. So finally, if I want to know the total amount of energy required, I would add each one of these individual energies together, and that would give me the total amount of energy required. Now, keeping in mind these numbers, 63, 33.4, and so on, we can look at an energy diagram for water. So this particular picture shows this process for 1 gram of water at minus 30 degrees Celsius. It started off, so on the vertical axis is temperature, and on the horizontal axis is energy. And so the first thing is the ice was at negative 30, and it got up to 0 degrees Celsius, and here it shows us the energy required. They have 62.7. It's probably using slightly different numbers for specific heat capacity. And then once the ice got to 0 degrees Celsius, its temperature stayed the same as energy was added. And the amount of energy that was added is the difference between 396 and 62.3 was 333.3 joules. And so the amount of energy required to change from ice to water was the number that we had earlier. Now I have water, it's at 0 degrees Celsius, and I want to figure out, I want to change its temperature to 100. And so there's a certain amount of energy required for that. And in my picture, it's 815 minus 396, which is 419, which is basically what we got earlier. And then I now have my water at 100 degrees Celsius, and I want to convert it into steam. And so I have this process, and over here is the final energy to convert it into steam, and over 815, and I get 2,255. So when I compare all of these, what required the most amount of energy was to take that water at 100 degrees Celsius and convert it into steam, right? This line is really very long. It took a lot of energy. This question had a little more to it if you wanted to continue and get that steam up to 120 degrees Celsius, which we did not do. What required the least amount of energy was to convert the ice, to change the temperature of the ice, right? And to change the temperature, to change the phase from ice to water versus changing the temperature of the water, they were pretty close, right? So it still required more energy to change the temperature of the water versus to change the phase. So these are some examples of how you can use these concepts of energy added to change temperature and energy added to change phase, and to look at the process in terms of a multi-step process.